what if you had a set of data and wanted to make sense of it? That's where likelihood-based inference comes into play. So, let's delve into what this concept really is. Likelihood-based inference is a statistical method that uses observed data to estimate the parameters of a statistical model. It's all about calculating the likelihood of a particular set of parameters, given the data we have. But why is this important? Well, in the world of statistics, understanding and interpreting data is key, and likelihood-based inference is a powerful tool that allows us to extract meaningful insights from our data. To give you a brief overview, this method works by maximizing the likelihood function to estimate the parameters. It's like piecing together a puzzle, where the pieces are your data and the picture you're trying to form is your statistical model. This statistical concept may seem complex, but it's fundamental to understanding data. Now that we have a basic understanding, let's delve deeper into how likelihood-based inference works. Picture a likelihood function as your own personal detective. It's trying to solve the mystery of how likely our observed data is given a set of parameters. It's like saying, given these characteristics, how likely is it that we'd observe this data? Let's illustrate this with a simple example. Imagine you're trying to estimate the average height of people in a city. You can't possibly measure everyone, so you take a random sample. The likelihood function then asks, given this average height, how likely is it that we'd get this sample? It's the detective trying to solve the height mystery. But we can't just stop there. We need to find the most likely parameters, and that's where maximum likelihood estimation, or MLE, comes into play. MLE is like the detective's magnifying glass, helping us zoom in on the parameters that make our observed data most likely. With our height example, MLE would look at different average heights and select the one that makes our sample most probable. Think of it as the detective saying, based on the evidence, this is the most likely average height for the city. At its core, MLE is a method of estimating the parameters of a statistical model. It's a powerful tool that allows us to make well-informed estimations about our data. But remember, like any detective, our likelihood function and MLE aren't infallible. They're based on the data we have, and there's always a chance of error. We need to be careful not to overinterpret the results or make sweeping claims based on our estimations. So the key here is to find the parameters that make our data most likely. That's the essence of likelihood-based inference. By understanding this, you'll have a powerful tool at your disposal for making sense of the world around you. Now, isn't that something worth investigating? Let's quickly recap what we've learned about likelihood-based inference. We've traversed a path that took us from the definition of this concept, a statistical method used to estimate the parameters of a certain model, to the intricacies of a likelihood function, which essentially measures the goodness of fit of a statistical model to data. We delved into maximum likelihood estimation, or MLE, a powerful tool that helps find the parameter values that make the observed data most probable. It's like finding the sweet spot where our model's predictions align best with reality. We also underlined how vital this concept is in the realm of statistics and data analysis. Likelihood-based inference is akin to a detective's magnifying glass, helping us scrutinize data, make sense of it, and draw meaningful insights. Remember, understanding likelihood-based inference is a crucial step towards becoming proficient in statistics. So keep studying, keep analyzing, and you'll become a master at making sense of data.